All right, going on to page 3. So to solve the equations, show your work and check for extraneous solutions. Remember, in our cases here, only our logs can have possible extraneous solutions, so that's the ones we'll be checking. For this first one, it's a natural log, so the only way to get rid of a natural log is to exponentiate both sides with e. When you do that, ln and e cancel, and so you get 6x plus 5 is equal to e to the 7th power. Now we're going to subtract 5 from both sides to get 6x equals e to the 7 minus 5. And then lastly, divide 6 off of everything to get x is equal to e to the 7 minus 5 all over 6. I guess I'll just type that into a calculator. So we have e raised to the 7th power, then minus 5, and then we'll take all of that and we will divide it by, not 5, divide it by 6. So that gives us 181.94. And then we'll plug that in. So we have the natural log of 6 times 181.94, and then plus 5. Yep, gives us 7. So we're good. Really, the only thing you're looking for with logs and natural logs is negative numbers, because those are the ones that are going to be not good to go in there. All right, on this next one we're taking a look at, we have 2 logs. So in order to solve this log, we need to condense it into 1. That way it's an isolated log. So we're going to condense. Remember, addition is multiplication when you condense. So x times x plus 1 is equal to 1. And then we distribute the x into here. So we get log base 2 of x squared plus x is equal to 1. And then we exponentiate 2 to both sides. That log base 2 and this 2 will cancel to leave us with x squared plus x is equal to 2 to the 1st power, which is just 2. Subtract 2 from both sides to get x squared plus x minus 2 is equal to 0. And then this should factor. We have x and x. We have positive and negative. Looks like positive 2 and negative 1. So then our x values that could possibly work are negative 2 and x equals 1. Let's plug them in real quick into this equation. If we plugged in negative 2, it would make this log negative, so we're done plugging in negative 2. It's extraneous. Can't use it. Let's plug in 1. We plug in 1 right here. Remember, log of anything of 1 is just 0, so that would give us 0. Plus, we plug in a 1 here. That's log base 2 of 2, which is 1. 0 plus 1 does give us 1. So x equals 1 does work here. This next one got a lot of good questions about 25 in class today. So if we're looking at 25, we have an isolated log, okay? The common mistake was we can't do that because that x is not being raised, that 3 is not being raised to the x. So instead, we have to exponentiate first because we need to get rid of this log. So that's going to give us 3x is equal to 9. Divide both sides by 3 to get x equals 3. You plug 3 into this, right? 3 times 3 is 9. Log base 3 of 9 is 2. So we're good. (26). So 26 is one where you could technically put it all together, but log base 2 on one side, log base 2 on the other side, because they're the same base and it's the only thing on each side, we physically can just drop them, okay? And that's because, right, if you would just exponentiate both sides right away, they would just literally cancel. And we would just be left with x plus 2 equals 3x. So we can just physically drop those logs. Subtract the x to the other side to get 2 is equal to 2x. Divide by 2 to get 1 is equal to x. Plug in 1, so that's log base 2 of 3. Plug in 1 on this side, that would also be log base 2 of 3. So it's good. 1 does work. All right, 27. So 27, another maybe a little bit trickier one. 3 and 27, how are they related? That's what you need to ask yourself, because they're not the same base, but we can make this 27 into a 3 by saying that's 3 cubed. 3 cubed is 27, so it's still raised to the x. And then on the other side, we have 3 to the 2x plus 3. We need to distribute this, so we have 3 to the 3x is equal to 3 to the 2x plus 3. And then to solve this, you could log base 3 of both sides, or you can just say, okay, these will just go away if we log base 3 both sides. So this is 3x equals 2x plus 3. Subtract 2x to get x is equal to 3. All right, and that one's going to work. So we're good there. All right, 28. Need to isolate the exponent in order to solve this question. So we subtract 16 from both sides to get negative 3 e to the 2x is equal to negative 11. Divide by negative 3 on both sides to get e to the 2x is equal to 11 thirds. Because it's e, the way to get rid of e is natural log both sides. So we'll do that. Natural log and e would cancel to leave us with 2x equals the natural log of 11 over 3. And then that would be divided by 2. So if we did natural log of 11 divided by 3, close that parenthesis here, and then divide that by 2, that's going to give us 0, I should say approximately 0.650, I guess, when you round that up. All right, moving on. So number 29 here, we need to first discover how can 4 relate to 1 over 32. Well, 4 and 32 are both perfect powers of 2. So that would be 2 squared would be 4. So we're going to go 2 squared, x minus 5. 1 over 32, we get 2 and raise it to the negative 5th power. That would make 1 over 32. And then that's raised to the 2x minus 1. Distribute the 2, so we get 2 to the 2x minus 10 is equal to 2. Distribute the negative 5, so negative 10x plus 5. Again, here's one where we can just drop the 2's. All right, they don't cancel across, but if you would just take log base 2 of both sides, they would go away, right? So that's 2x minus 10 is equal to negative 10x plus 5. And then we're solving for x here. So that's going to be 12x is equal to 15 divided by 12 to get x is equal to 15 twelfths. And then reduce it. That is x is equal to 5 fourths when you divide both of those by 3. All right, and then number 30. Number 30, we add 5 to both sides to isolate the exponent. 3 to the x minus 2 equals 11. And then we can log base 3 both sides to cancel out the 3. Wow, I can't really see that at all. Here, I'll do this. So log base 3 both sides, cancels the 3, so we get x minus 2. Type in log base 3 of 11, or you can do it at the end. Either one is fine. So add 2 to both sides to get x is equal to, and then when you type this in, we need log of 11 divided by log 3, because we need to use our change of base to get a decimal there. And then we go plus 2. So this is 4.183. And again, probably saying approximately is the best there for that. All right, awesome. Last thing on the third page is going to be our word problems, which word problems need an equation here. So let's see if we can't make this work like this. All right, sweet. So we deposit $2,000 into an account that pays 2% annual interest compounded quarterly. How much is in the account after 20 years? Compounded quarterly means that we're using our compounded equation. So this is P times 1 plus R over N to the NT. That's our compounded equation. for things that happen a set number of times in a year. So we deposit $2,000, so $2,000 is our P, or our principal, and then the account pays 2% interest compounded quarterly, so that's 1 plus 0.02 divided by 4 raised to the 4 multiplied by, in this case, 20. So then we can just type that in, so that's 2,000. 2,000 multiplied by 1 plus, and then I'm going to put this in parentheses, 0.02 divided by 4. Then I'm going to close that parentheses, close the next parentheses, and raise it to parentheses 4 times 20. So it all goes in the top. So then my final answer that I get is, this is dollars, so 2,980.68. All right, next up, it says you deposit $100 into an account that earns 3% annual interest compounded continuously. Continuously is PERT. So we have 100 E raised to the rate, which is 0.03, multiplied by T, which we actually don't know in this case. We're wondering how long does it take for this account to hit 200. Talked about two ways in class to do this. The first way was to set your y1 equal to the left side, set your y2 equal to the other side, so that's E raised to the 0.03, and times, actually I need to put that in parentheses, so 0.03 times x. Bam. Okay, scroll out just a little bit so we can see this thing. Oh wait, I need to put y equals here because we're in Desmos. Y equals, and there we go. So our t value is approximately 23 years. So in this case, 23, so approximately 23 years. By all means, you can also solve this one by hand, right? In order to solve this by hand, we need to isolate the exponent. So we're going to divide both sides by 100. That's going to give us 2 is equal to e to the 0.03t, ln both sides. To get the ln of 2 is equal to 0.03t, divide by 0.03. Let's see what that gives us. So that's the ln, natural log of 2, divided by 0.03. Yeah, and there we go. So approximately 23 years again. So both cases work, right? Graph it or solve it by hand. Both awesome ways to do that question. 33, Bob deposits $700 into an account that pays 6.5% annual interest compounded continuously. Find the balance at the end of 7 years. So this is another PERT because it's continuous. We have 700 to start, E raised to the R, which is 0.065, and then multiplied by T, which is 7. This one's a little bit nicer because we can just plug it straight in. 700 E raised to the R, 0.065. Whoops, need to put that in parentheses. Parentheses. 0.065, and then times 7. Close that parentheses. That's going to give us 1103.32. And again, this is all money, so we'll just put that money sign there. Money, money. All right, last one. Snooki bought an iPod. Oh my gosh, it's been a while since we've updated this review sheet. Snooki bought an iPod for $225 in 2009. If the iPod decreases in value by 6% each year, how much will the iPod be worth in 4 years after the purchase? So 2013. So this one, we're going our per P times 1 minus the rate because it's decreasing in value raised to the T. So it decreases by 6% each year. So we started with 225, 1 minus 0.06, and then we're doing it for 4 years. So we can just type that in, 225, parentheses 1 minus 0.06, close parentheses raised to the 4th power. So it's going to be approximately $175.67. Granted, I mean, if you're buying a famous person's iPod, it's probably going up in value the longer they own it, but who knows? Who knows? Anyway, that is all of the Unit 6 review. If you have any questions on anything that I did in this, please message me on Canvas. I would love to talk to you about anything you're struggling with. Other than that, I hope you have a great day.